Today we're going to look at exponential functions. The first thing we're going to need to know is what a exponential function is. Notice that if we have something like 2 to the x, that is exponential. If we have something like x squared, that is not. The difference is if there is a variable in the exponent. If there is a variable, the x is inside of the exponent, that's what makes it an exponential function. You may remember talking about these in Math 1 or maybe even in a science class, but we're going to go over the basics again just in case you may have forgotten. The base is the number being raised to a power. So a lot of times I'll have an exponential function that looks like this. This exponential function has a base of 3 because 3 is the number being raised to the power. That is my base. And my starting value, which a lot of times I refer to as a, is the number in front. So the general form of a basic exponential equation is a, the starting value, times b to the x. If the base is greater than 1, so in this case 3 is definitely greater than 1, that's exponential growth because multiplying by a number bigger than 1 will make you grow. And this is going to be 2 times 3 times 3 times 3 times 3 over and over, however many times x is. If it is a number smaller than 1, it's going to be a decay, because if I had something like this, 10 times 1/2 to the x, every time I multiply by 1/2, I get smaller. 10 times 1/2 is 5, times 1/2 again is 2.5. So anytime you're multiplying by a number between 0 and 1 is going to be a decay. If it's a number bigger than 1, it's going to be a growth. Multiplying by 1 doesn't change a thing, so we always, to find how fast I'm growing and decaying, I subtract 1 from the base. So in this case, my base is 2, so that is definitely a growth. My rate of growth, I do 2 minus 1 is 100%, because I increase rate of 1. If I make it a percent, I just move the decimal 2 places, so 100%. And the y-intercept, or the starting value, is the number in front, 3. Okay, on this one, this is a decay because it's smaller than 1. To figure out how much smaller than 1, I do 1 minus 0.3, which is 0.7, which is 70%. Always move the decimal 2 places to make it a percent. And then the y-intercept is the number I'm multiplying by in front. And this time you don't see something multiplying in front. So the truth is it's an understood 1 in front of that. So the y-intercept is 1. If you don't see something in front of your base, it's an understood 1. This one is also bigger than 1, so it's a growth. Figure out how much bigger than 1, 1 minus 1.5. So that is a 50% growth. Actually, probably should have done 1.5 minus 1, but if you ever do those backwards and get a negative, as long as you know it's a growth, it does not, you can ignore the negative or positive. If it's bigger than 1, it's growth. If it's smaller than 1, it's decay. The y-intercept is the number I'm being multiplied by in front. In this case, it's a negative, so that's an understood -1. So the y-intercept is -1. One more we're going to do together. Might want to pause your video and get these down, and then we'll try 4. They're trying to be tricky because you notice that they have not just given you a x in the exponent, they've stuck a 2x in that exponent. So the first thing I have to do is simplify this and say that's going to be 5 times what to the x. So basically, to figure that out, I can just simplify and do 0.8 squared, which is 0.64. So that's your first step before you do anything else. Now, since 0.8 is smaller than 1, it is going to be a decay, but you wouldn't be able to find the rate of decay without simplifying that. So in this case, it's a decrease, and then I can do 1 minus 0.64 is going to be a 36% decrease, or 36% decay. So if they give you a weird one with something else in the exponent, that's what you do to figure it out. So go ahead and try the rest of these. If you got any questions, I'll be available in Zoom. Beware, number 9 is another tricky one where you have to simplify it first.